The future of autonomous vehicles, AVs, represents one of the most significant technological shifts of the 21st century. While much of the technology is still under development, the potential for AVs to transform nearly every aspect of society is profound. The transition from manually operated vehicles to self-driving ones will not only alter how we travel, but also reshape urban landscapes, economies, and regulatory frameworks. Below is a more comprehensive look at the future of autonomous vehicles, examining the technological, economic, societal, and environmental impacts they could have. 1. Full autonomy, levels of driving automation. Current state. Most AVs today are in the early stages, with technologies operating at Level 2, driver assistance, or Level 3, conditional automation, according to SAE International's levels of driving automation. These systems may control the vehicle under certain conditions, but human drivers are still required to supervise and intervene when necessary. Future state, Level 5. The ultimate goal is Level 5, where a vehicle can drive itself in all conditions and environments, requiring no human input. In this scenario, there would be no need for a steering wheel, pedals, or driver's seat. Achieving Level 5 involves solving complex problems in AI, machine learning, sensor integration, and safety. Technology development. Achieving Level 5 autonomy depends on advances in various fields, including AI and machine learning. AVs need highly advanced algorithms that enable them to perceive their surroundings, predict potential hazards, and make complex decisions in real time. Sensor technology. Sensors like LiDAR, radar, cameras, and ultrasonic sensors must be perfected to function in all weather and lighting conditions. These sensors will need to work in perfect synchronization to provide a holistic understanding of the vehicle's environment. Map and localization technologies. Autonomous systems require highly accurate maps to navigate urban and rural environments. As AVs continue to develop, real-time map updating and simultaneous localization and mapping SLAM technologies will be critical. 2. Transportation as a service, TARS, shift toward shared mobility. One of the most transformative aspects of AVs will be the shift from personal car ownership to shared mobility services. As self-driving cars become more reliable, services like ride-hailing, Uber, Lyft will evolve into fleets of autonomous vehicles, fundamentally changing the transportation landscape. Autonomous ride-hailing. Companies such as Waymo, Google's autonomous car subsidiary, Cruise, a subsidiary of General Motors, and Tesla are already testing autonomous taxis. These fleets of driverless cars could eventually become a mainstream solution for urban transportation. Mobility as a service, MaaS. Autonomous vehicles could be integrated into MaaS platforms where individuals access a variety of transportation options, e.g. AVs, shared bikes, electric scooters, through a single, seamless app. This integrated ecosystem could lead to more efficient urban transportation systems that reduce the need for private vehicle ownership. 3. Urban infrastructure and smart cities. As AVs become more prevalent, urban infrastructure will need to evolve to accommodate these new vehicles. Smart cities, where infrastructure is connected and optimized for AVs, will become the norm. Intelligent traffic systems. AVs will rely on vehicle-to-everything, V2X communication, where they communicate with each other, traffic signals, road signs, and even pedestrians to optimize traffic flow. Smart traffic lights, for example, could change in real time based on the presence of AVs, reducing congestion. Infrastructure adaptations. Roads, highways, and bridges may need to be redesigned for AVs. This could involve creating designated lanes for AVs, ensuring roads are equipped with sensors that communicate with vehicles, and ensuring that the surfaces are well maintained to meet AV requirements. Parking. Reimagined. With autonomous vehicles, the need for vast parking spaces will diminish. AVs can drop passengers off and then park themselves in less crowded, more efficient spaces, or even continuously circulate in fleets to optimize their utilization. In urban areas, parking garages could be repurposed into residential or commercial spaces. 4. Safety and traffic flow reduction. In human error. A major benefit of autonomous vehicles is the elimination of human error, which is responsible for over 90% of traffic accidents. AVs, equipped with sensors and AI-driven decision-making, will follow traffic laws precisely, communicate with other vehicles, and avoid collisions through predictive algorithms. Collision avoidance. With the ability to process data from hundreds of sensors and make decisions in milliseconds, AVs can react much faster than human drivers, potentially preventing accidents. Safety features. AVs will also integrate features such as automatic emergency braking, lane keeping assistance, and adaptive cruise control to ensure a higher level of safety. The advanced systems can also analyze real-time traffic conditions, reducing accidents caused by driver distraction or fatigue. 5. Environmental impacts. Reduced emissions and energy efficiency. Many future autonomous vehicles will likely be electric, reducing the carbon footprint of transportation. AVs will optimize routes and driving patterns to increase fuel efficiency and reduce energy consumption. By driving at consistent speeds and avoiding rapid acceleration or hard braking, AVs could reduce fuel consumption and greenhouse gas emissions. Less congestion, less pollution. AVs will optimize traffic flow, potentially reducing gridlock. With fewer traffic jams and smoother traffic movement, overall air pollution in urban areas could decline. Moreover, shared AVs could reduce the total number of vehicles on the road, decreasing overall emissions. Fleet management and optimization. Autonomous electric vehicles, when used in shared fleets, could provide a shared economy solution that reduces the total number of cars on the road. This shift could significantly reduce emissions, especially if the fleets are integrated with renewable energy sources like solar power. 6. Economic and job impact. Job displacement. The advent of autonomous vehicles will lead to job displacement in several sectors. Professional drivers, truck drivers, taxi drivers, and delivery drivers are at high risk of job displacement. The U.S. Bureau of Labor Statistics estimates that nearly 3.5 million truck drivers could be affected by automation. Vehicle maintenance. With fewer humans behind the wheel, there may be fewer accidents, but the complexity of AVs could also require specialized technicians for repair and maintenance. While some jobs will disappear, others, such as in the AI, software, and cybersecurity fields, will emerge. New business models. Autonomous vehicles will lead to new business opportunities in the form of fleet management, data analysis, and AV-related services. The mobility as a service model will create entirely new sectors such as AV fleet management companies, software providers, and infrastructure developers. 7. Regulatory, legal, and ethical challenges. Regulation and legal frameworks. As autonomous vehicles become more prevalent, governments will need to establish comprehensive regulations that address issues like liability. Who is responsible in the event of an accident involving an autonomous vehicle? The manufacturer, the software developer, or the owner? Insurance. Traditional auto insurance models may need to be restructured, as liability might shift from drivers to vehicle manufacturers and software developers. Data privacy. Autonomous vehicles will collect vast amounts of data on drivers, passengers, and the vehicle's surroundings. How this data is stored, shared, and protected will raise important privacy concerns. Ethical issues. AVs will face ethical dilemmas, such as how to prioritize lives in unavoidable crash scenarios, the trolley problem. Determining how AVs make moral decisions will be a complex task for developers, policymakers, and ethicists alike. 8. Cybersecurity and safety concerns. Autonomous vehicles will be highly connected and reliant on software systems, creating potential vulnerabilities to cyber attacks. Hackers could potentially manipulate vehicle behavior, leading to safety risks. Security measures. The industry will need to implement robust cybersecurity protocols to protect against unauthorized access and ensure that AVs operate safely and as intended. Over-the-air updates. Manufacturers will need to develop secure ways to push software updates to AVs in real time to fix vulnerabilities and enhance safety features without compromising vehicle operation. 9. Public perception and adoption. Trust and acceptance. The widespread adoption of AVs will depend significantly on public perception. Concerns about safety, reliability, and privacy will need to be addressed. Education and transparent communication from manufacturers and regulators will be crucial to building trust in autonomous technology. Gradual adoption. AVs will likely be adopted gradually. Initially, they may be restricted to specific use cases such as urban ride-hailing, goods delivery, or in controlled environments like highways or industrial parks before transitioning to broader, unrestricted deployment. Conclusion: a transformed future. The future of autonomous vehicles is a complex and multifaceted evolution that will reshape not just transportation, but also urban design, the economy, and society itself. Plus, like, share, and subscribe to our channel for more tech-related videos. Also comment any video you did like to see in the future, and we would get it done. Peace.